Hi, welcome back to Physics Teacher, the channel that prepares you for the high school Waterloo math, physics, and chemistry contests. This is the last question in the Pascal contest from year 2021, and it's the grade 9 math contest. Give it a try, and I'll be right back with the solution. Alright, so this question has a set of consecutive integers starting at 1 and going up to some unknown integer n. And then Jan removes 4 integers from the set. We don't know which 4, but we know that 3 of them are consecutive and they're all greater than the number 100. After he removes those 4 integers, the remaining integers have an average of 89.5625. The question says, what are all the possible values for s? Alright, so we originally start with n integers, and after we remove 4, we have n minus 4 integers. So I'm going to call s the sum of these integers. And I also know that the average of these integers is 89.5625. I want to split this into a fraction, so let me break this apart. I'm going to have it as 89.5 plus 0.065, and that reduces to 89 plus 0.5, which is a half, plus 0.065, which is a 16th. And so I can now write that as 89 and 9/16, or as a mixed fraction, 1433 over 16. And the average is equal to the sum divided by the total number of integers that you added, which is n minus 4. So here we have this equation to start. And I'm going to rearrange it so that it looks like this. We have 16s equals 1433 times n minus 4. Now, because 1433 is not divisible by any divisor of 16 other than 1, n minus 4, and this is very important, n minus 4 must be a multiple of 16. Alright, so that's our first big piece of information we're going to need to solve this problem. So let's look at something else then. So it says that all 4 removed integers are greater than 100, and after removing them, the remaining average is about 90, or close to 90. Well, since we would then therefore have more than 100 integers in the original set, removing 4 isn't going to change the average by very much. So we can assume that the original average was pretty close to 90. And because this is simply adding consecutive integers, we can say the average is also just the first integer plus the last integer divided by 2. Right? For example, if you had 1, 2, and 3, well, the average, yes, it's 3 plus 2 plus 1, which is 6 divided by 2, which is 3, but it's also the first one, 1, plus the last one, 3, which is 4 divided by 2. You get the same result. And in our case, our first one is just going to be 1, and b is going to be n. So 1 plus n over 2. Now let's say we remove the 4 largest integers. So if Jan removed the 4 largest integers, then our set, so I'm going to write largest, our set would start at 1, 2, 3, and go all the way up to n minus 5 and n minus 4, and that's it, because we removed the 4 largest ones. So that would mean the average of that is 1, the first one, plus the last one, n minus 4, divided by 2. And that can be reduced to n minus 3 over 2. However, if Jan removed the smallest integers, and even though they must be greater than 100, I'm creating a range here. So let's remove 1, 2, 3, and 4. So we're left with 5, 6, all the way up to n minus 1 and n. Its average would therefore be the first number 5 plus the last n divided by 2. So what this tells me is whichever 4 integers Yan removed, I know that the new average, let's call it A new, the new average is going to be greater than or equal to n minus 3 over 2, and it's going to have to be less than or equal to this n plus 5 over 2. So if I multiply all through by 2, I know it's n minus 3 is less than or equal to twice the average, and this is the average, 89.5625. So twice that is 179.125, and must be less than or equal to n plus 5. Now since these are integers, I'm going to round this average to 179. And when I do that, I can say then that n must be greater than or equal to 175 or less than or equal to 182. And if I subtract 4 to figure out what n minus 4 would be, it must be greater than or equal to 171 and less than or equal to 178. Now remember, in our first slide there, we determined n minus 4 must be divisible by 16. Well, there's only one number that's in between these two values that's divisible by 16, and that is 176. So n minus 4 must be equal to 176, or n is 180. So we've just determined that in the original set, we had the integers 1, 2, 3, all the way up to 180. So there's our second piece of information that we're going to need. Let's continue. All right, so in our new list, after 4 integers have been removed, we have the sum divided by the total number of integers is equal to our average, which is 89.5625. Now I know what n is now, so I could figure what the sum of all those integers are. It is going to be n minus 4, which is 180 minus 4, times by that average 89.5625. And so we know now that the sum of our new list is 15,763. Well, what about the original list, so the old list, before 4 integers were removed? What was its sum? Well, let's say its sum was, I'm going to call it t, and it had a total number of n integers, and its average would have been its first number plus its last number divided by 2, since they're all consecutive. So rearranging to solve for t, we get n times 1 plus n all over 2, where I now know that n is 180. So we have 180 times 181 over 2, or the original sum was 16,290. So if I find the difference between these, so the difference is going to be 16290 minus 15763, that is going to be 527. So what does that tell me? That tells me that these 4 integers that were removed, p plus q plus r plus s, have a sum of 527. Now I also know that these values p, q, r, s are greater than 100, and we know that they are less than or equal to 180, since we have a total number of 180 original integers. And remember, I also know that 3 of them are consecutive. Don't know which 3, but 3 of them are consecutive. Alright, so if 3 of them are consecutive, we could have one of them be as large as 180. So if I made one of them 180, that would mean that the other 3, p plus q plus r, would be 527 minus 180, which is 347. So that is the smallest possible value you can have for the sum of these 3 consecutive integers. However, if I made one of them equal to 100, then we are left with p plus q plus r would be equal to 527 minus 100, which is 427. And that's the greatest value that our consecutive integers would add to. So let's look at these least and greatest. So least, well, if we add 115 plus 116 plus 117, we get 348. That's as close as we can get to 347 without going lower. And that would mean that the fourth value then, the fourth integer, in order to add to 527, would be equal to 179. Where our greatest values, to add to 427, we would have 141 plus 142 plus 143. That equals 426. That's as close as we can get to 427 without going over. That means the fourth integer would be equal to 101. Now if we continue this pattern by simply adding 1 here, so instead of 115 we have 116 plus 117 plus 118, we've added a total of 1 to each integer, so that means our fourth integer would be subtract 3, so you would have 176. Now over here you do the same thing, but we're going to subtract 1 from each integer, so we have 140 plus 141 plus 142, and our fourth integer to add up to 527 would need to be 104. So in this case we're adding 3, and in this case we are subtracting 3 to that fourth integer. So what is our value of s in each case? So s is the greatest integer here. So in the least cases, this would be s, and this would be s. And starting from the most cases, that's our largest integer, and that's our largest integer. So here we're subtracting 3, and here we're adding 1. So if we follow the least case, let's call this set 1. And if we keep going, we have 179, 176, 173, and so on. And if you did the same thing following the pattern in our most one, we're going down from 143, one integer each time. And at that point, we can't go any lower here or here, because then our numbers start to overlap. And you can't have them overlapped because they are for distinct integers. They're not going to be the same integers. We're pulling them from this set. And also, if you look at these values for s, we have some overlapping here as well. So we have 143 here and here. So we can't count the same thing twice. Let's get rid of one of them. Similarly, here we have 140 here and here. So let's get rid of that one. We have 137 here and here. So get rid of one of them, and 134 here and here. So if you count the remaining, there's a total number of 22 possible values for s. And there's our answer.